expert of computer vision, we start this journey from very specific, that is image
processing. In this tutorial I focus on practical machine learning and particularly on image processing, methodologies and algorithms. Applications using various Python libraries, and real-time use case implementation using machine learning approaches. Before starting the actual scenario, I assumed that know these terms: images, pixels, image resolutions, different image file formats and color space. Let's start our tutorial from very interesting library of Python scikit-learn, especially we are targeting scikit-image. Doing image processing without using a programming language is like counting the number of stars as you stare at the night sky. There are so many complex methodologies that, even if we try to do it manually, it's not at all possible. But, if we use programming languages such as Python, R, C++, MATLAB, and so on, the same work can be done in a jiffy. Scikit-image is a module that is used to do basic image processing. Before we start, let's look at the definition of a module. A module is a collection of Python files, classes, or functions. We can save complex and lengthy code inside different files. To do this, we need to import the files and use them in our environment. First we need to import scikit-image into our environment, like so. First thing first, to import the required module, we use here a keyword import to use any library or module that we call scimage. Scimage module contain different image processing algorithm. At the line of code we want to upload and view the image, we use a class from the scimage module called IO. Inside this class we use the imread function to upload and read an image. One thing you must remember, that the picture on which you want to perform these operations must be in your root directory, mean that the picture is present in your virtual environment root directory. The last line of code you see the imshow function which is used to view the image. Okay, your first requirement's been completed, so very interesting. Now move forward to the next step. At this step we want to get image resolution. First and second line of code we have already discussed. Let's come to the last line of code which contain a function of shape. And this is function which is used for image resolution. We use this built-in function when we need to read an image. All the pixel value are stored in an array format. This array is called a numpy array. After we read the image and convert it to array, we use shape function. To look at the resolution in the code, you see that we have an image with a resolution of 1536 by 2048 and it has 3 channels because it is in the red, green and blue color format. Now that we know the resolution of the image, we may want to look at each pixel value. To do this, we save the numpy array in one line. In other words, we use one row to store all the pixel values. When you look at the code that follows, you can see we are importing another module named pandas. Pandas is used to read, write, and process various file formats. Here, we save the pixel values in the Excel format. When we look at the importing line import pandas as PD, it means we are renaming the imported module to PD. The flatten function is used to convert the 3 dimensions of a red, green, blue image to a single dimension. We then save that image in an Excel file named .xlsx. To do this, we use the pandas function called to_Excel. The data frame function converts a one-dimensional array into an Excel-like format, with rows and columns. You can print the df variable to look at the data frame structure. This is sufficient for your first tutorial. In the next tutorial we will start from how to convert color space of an image. Subscribe, like and share my effort. Thanks.